Hi all. In this video, I would be discussing CM1 Paper B for September 2022 term. So the solutions are true and best of my knowledge, although there might be errors and you all are free to comment for that on the comment section. Okay, so first, an insurance company has estimated the independent probabilities of two decrements in the population of healthy lives. These are set out in the worksheet. Question 1 based transitions can occur out of the healthy state in one of the two absorbing exit states, ill health or death. Healthy, ill health. Forces of decrement are assumed to be independent and constant over individual years of age. Construct a double decrement table using the template provided for integer ages 50 to 110, assuming a radix of AL50 is equal to 100,000. So in the sheet, you have been provided this base where we have been provided the mortality of QXD, QXI, and we've given other details. For the first part, we need to calculate the mortality rate, double decrement table. So from this table, we've just pulled out the mortality and the probability of ill health both. So QXI and QXD from these tables. And then you can calculate the mu x, which is nothing but minus ln of 1 minus QX from this table for both mu and sigma, which are the two decrements, death and ill health. Then we can calculate the total force D3 plus E3. APX is nothing but e to the power minus of total force. AQX is nothing but 1 minus APX, and AQXD, which is the decrement, is the mu x by mu x by total force into AQX. And similarly, AQXX will be sigma x by total force into AQX. So this will give me the entire table till 110. So this is the first step in this. Now main the double decrement table. We have been given the value of ALX as 100,000. We can calculate ADXD and ADXL using this. ADXD is nothing but 100,000 into AQXD, and this is 100,000 into AQXS, and then this is this minus this will be the remaining people in this total year. So these are the two double decrement table we get. Then we have evaluate the probability that the healthy individual aged 65 will leave the population by ill health or death before 71st birthday. So before 71st birthday, a person who is currently aged 65. So probability of leaving the population at age 65, number of people who leave the population due to ill health. Okay, that is now total number of people divided by the number of people at age 65, which is ADX this, and then probability of the leaving the population through death. So if the death number of people leaving through death divided by the total population at that point of time at age 65, and then we have the probability of leaving through death or health benefit is this plus this, the total probability. Okay, or we could have summed the entire thing together and divided it by together, or divided it together again. The number of people dying due to ill health plus number of people dying due to death divided by the number of people alive at age 65 will give me this entire probability. Now, next is insurance company offers a temporary assurance policy to a healthy individual aged 52 exact. Details of the policy and the premium basis are set out in the worksheet Q1 base. Calculate the premium for this policy expressed as a percentage of salary using the equivalence principle. So now we have to use the equivalence principle to calculate the salary. So we have been set out details over here that is a 20-year term and benefit on ill that is 50% of the salary payable annually in advance for a fixed term of 5 years. And then a lump sum of 4 times the salary. And then we have payable in annually in advance premiums. And premiums also increase in line with the policyholder salaries. Salary increases are 3% per annum occurring on the anniversary of entry. Salary on entry is 45,000. Policyholder age at inception is 52 and 4.25% per annum expect. This is 2.5%, and so on. All these details have been given here, and we have just put the details over here as well, just for our convenience of calculation. We have pulled AQXD, AQXX, APX, and for our calculations for these ages 52 to 71, which is a term of 20 years. And then we have the TAPX, which is at the time of the policy, obviously buying the policy, the person is alive. Then from next year onwards, it will be F8 into 1 into this APX and so on, and will go on till end. Okay, this is just the cumulative APX. Then we have the salary. Salary increases 45,000 in the first, it's 45,000. Next year it is 45,000 into 1 plus 3% to the power time minus 1, which is the increases. Now, EPV of health benefits, it's an annuity certain of 5 years. So first we'll calculate the value of annuity certain 5 years, which is nothing but 1 minus 1 plus I, which is 4.2 to the power minus 5 divided by I, which is again, divided by D, which is 4.07 because it's an annuity payable in advance. So we calculate this, and EPV of death benefit is 0.5 into the salary value. So it's 0.5 into the salary value into this probability of dying into the ADU5 because it's an annuity certain, and into the discounting factor to the power of time. Okay, F4 to the power of, so this you can put in bracket, F4 to the power time. Okay, and the remaining things remain there. So we have salary, 0.5 into salary into the ADU factor, which is I1, into the probability, and into discounting to the power time. So that will have to be there. Okay. Then we have $334.92 F89 TAPX. This value will be yes. AQX is Okay, so EPV of AQXX into TPX also will be there from 1 onwards and going on till the end. EPV of death benefits is nothing, then 4 times the lump sum of the salary, 4 into the salary, into AQXD, into APXD, into the discounting factor, and into APXD as well. So this is the, this into T of APX as well. And then this is there for the entire, all the death benefits. Then we have the premium. Premium is again payable. Let's assume the premium. So let's assume premium to be 1,000. So if the premium is assumed to be 1,000, premium is increasing in line with the salary, which is 2.5% or 3%, sorry, 1 plus 3%. And then discounting, we have V to the power 0, then V to the power 1, time minus 1, and so on. And then we have EPV of premiums is nothing but the premium into discounting into TPX, and commission is commission is 30, initial commission 30% of the premium, and renewal commission is 2.5% of the premiums. And then we have EPV of commissions as well, which is TPX into discounting into present value. We have expenses, obviously, again, expenses, initial expenses 400 and renewal expenses 100. And then again multiplying it with TPA, APX, and so on. And then we can just use the equivalence principle, EPV of ill health benefits, EPV of death benefits, commissions, expenses. Equivalence will be what? All adding minus the EPV of premiums. Okay, this should be equal to 0. So data tab, what if analysis, goal seek to value, set cell to value 0. And by changing cell will be premium. So this gives me a premium of around 3317.141. Okay. So this is the first answer we get. Next question 2, which held almost 50% of the paper, 42% of the paper. A life insurance company has a portfolio of identical premium endowment assurances with a combined sum assured of 1.5 million. The outstanding term of the portfolio, the outstanding term of the portfolio is exactly 20 years, and the endowment assurance death benefit is payable at the end of year of death. The endowment assurances were paid by a single premium at the outset of the policies. The current age of all the policy holders is 30 exact. The company holds 3 assets A to meet its liabilities in respect of the portfolio. The basis is used by the company to together with the details of the asset is set out in question 2 base. Determine the present value of the insurance company's portfolio of endowment assurance and present value of assets. So this is very easy given our assets are listed over here and we have been given the QX for endowment assurances. We can easily take out the part for this. So I'll just show you all. Yeah. Let's see this part. I've done all together. So here in time, year over year, I've taken out all this sum assured. This is I 6% and so on. Age is given, QX is given to us. So we can just use VLOOKUP to get the QX. 1 minus QX is PX. TPX again starts from 1 and next value will be this into this. Discounting value will be V to the power time. Okay. And EPV of benefits is nothing but QX into TPX into discounting into the sum assured, which is fixed, and so on. And the last value will not be multiplied by QX, it will only be multiplied by TPX. Okay, since it's an endowment assurance. And the present value of this is 47212211. Similarly, for asset A, since the asset A has been said that's 55,000 nominal of a fixed interest with a term outstanding of 20 years, asset A is redeemable at 105 per 100 nominal. It pays coupons of 1% per annum half yearly in arrears. So we'll just take out that pays half yearly in arrears. So 0 to 20, there are 20 payments. It pays coupons of, yeah, half yearly in arrears, it will be. Yeah. So over here, we can see it's half yearly in as arrears. 0.25, 0.5, the payments are starting to 75 and so on for each coupon. Since it's payable at 55,000 into 1% divided by 2. And at the last, there's a redemption of 105%, so 55% into 105%. It gives me a redemption, and then the cash flows total I can calculate using this. And discounting factor is 1 plus 6% to the power minus of time. And then present value of this is nothing but cash flows into discounting factor, and sum of this will give me the present value of asset A. Then present value of asset B. Asset B is given. Asset B is told us that it is the zero coupon bond paying 300,000 in exactly 10 years time. So 300,000 into 1 plus 6% to the power minus 10 will give me the present value of asset B, and present value of asset C is 120. It's again a zero coupon bond with this value 1202946 into 1 plus I% to the power minus 25 years, since it says it's exactly 25 years time. So we have calculated all the present value. I have done everything in one sheet. You all can obviously do it in separate sheets given the split of the question. Then we have been told this was part 1. Then determine the volatility of the portfolio of endowment assurance and volatility of assets in respect of both portfolios. So first I'll just calculate the total value of the total present value of the assets. So total present value of the assets is, you can see, is equal to the present value of the liabilities. And then we have calculated the volatility of the numerator and denominator. So volatility of this is total volatility of this. How to calculate volatility numerator is basically the first differentiation. If you see, so cash flow into the cash flow value remains the same, that is sum assured into probabilities into the discounting into the time into 1 plus I to the power minus into discounting factor with added a 1 x with an extra time. Okay, that is plus 1 in the denominator, if you in the numerator. And this entire value sum is divided by then the present value of the liabilities. Again, here in the volatility, make sure that you do not multiply with the mortality probability. Only the survival probability needs to be multiplied for the last year. Then volatility of asset A is again the cash flows into the value time into 1 plus I to the power minus of time plus 1. Then we have volatility of asset B. Asset B volatility. This was 10 years and this was 25 years. So if you see the volatility of asset B, again, the same formula have been used. And I have just divided with the present value, which is over here. So it gives me the 9.433 and 23.55. And total volatility of all the assets, if I see, total volatility of all the assets is this. Whereas volatility of liabilities is 18.46. So there's a difference between the volatilities on the two assets. Then we have been told that the company now wishes to rebalance its holding of assets B and C such that the portfolio is immunized against small changes in the rate of interest. The holding of asset A will remain unchanged. Determine the new holdings of asset B and C. So it is mostly that the time of this holdings has to be changed rather than the amount, because the amount does not affect the volatility so much. There's a difference in volatility. I will not be able to obviously change my present value. Present value is almost same for both the asset and liabilities, but yeah, the holdings need to be changed, so it has to match. So if I do a simultaneous equations on this, I'll only be able to change the time on this. And if you change the time, what you can do is use the solver thing in your tab. So data solver, the set to 0, and if you see, I've just done this is to the value of 0 by changing variable cells T1 and sorry, this will be equal to 0 by changing variable cells T1 and T2. And T1 and T2 always has to be an integer and it has to be greater than 0. It cannot be minus. And we have made all unconstrained variables negative. So solver found a solution. If you see 2.82, or if I go to restore and return to original values. So if you just make it GRG non-linear and you solve, then this is the answer we get. So if you see, the answer we are getting is basically we see that there should not be any holding of asset B, means the asset B should not be held for any more years, they are saying, and it should not be held, and this asset should only be held for 2 years. Then it will meet the volatility condition, that volatility of assets is equal to the volatility of liabilities. Okay, if you see now, volatility of all the assets is equal to 18.64936, and this is also equal to 6.936, and our present values are also matching at these conditions. Yeah. So these are the volatilities if I see. But you might not change the reholdings as well because the initial conditions are matching. And then they have said demonstrate the Reddington's theory, that the Reddington's conditions are met with this new holding. So you've already calculated the volatility and the present value. Do not need to calculate it again. You only need to calculate the convexity now. So for convexity, if you see, convexity is again the same formula with the double differentiation for asset A, asset B, and asset C. But if you see, the convexity is failing, since convexity of assets will be coming less than the convexity of liabilities over here. So this won't match. And then explain without performing any calculations how relative values of assets and liabilities will change, decrease. So present value of assets, since this is not immunized to the small changes in interest rate because of third condition is not matching with the new holdings. So we will not be able to say that we'll be able to say that assets are falling when the interest rates fall, that the assets will increase by a greater amount than liabilities, or when the interest rates increase, assets will fall by a greater amount than liabilities. Okay. So this might be, or anybody might find holdings manually over here by changing the figures, if you all can. Okay, so that will change a bit. Then we have question 3. So question 3 is the finance director of a company has been presented with two potential projects. Project A streamlines financial processes. Further details of the project, including expected cash flows, are set out in the worksheet. And project B is the development of a new finance administration system. Finance director wants to implement one of the two projects and have asked you for a recommendation. The company has a policy of using an annual effective target rate of 6%. Determine the net present value. So we have been set out the project A details. In year 1, it is doing 1,500,000 for implementation, setup and testing. And this is how from year 2 onwards, it is how 1 lakh rupees in maintenance, and from savings, it's from year 2 onwards, and from 3 onwards, increasing by 0.5. So you can just read the conditions and put the values. So 1,500,000 and then 100,000 each year. Staff savings, this is increasing by 0.5% each year. Again, additional staff savings is also increasing by 0.5% each year. Then discounting, we have taken, they have given an assumption that cash flows occur halfway through the year. So we can just take a discounting that each cash flow is occurring halfway through the year at 0.5 or at 1.5 or at 2.5 and so on, and at 9.5. So we just bring down to that. And we can calculate the present value of this net present value of this project. Similarly, for project B, we can calculate the net present value given the data is very easy. It's 255,000 increasing at 2%. Then 500,000 for all these are given, and again halfway through the year. So you can just put in the values that these only for 2 years, and then these savings are put into from time 3, then 500,000 and this, and 100,000 for each year, and an entire NPV for each of the project is calculated. Both NPVs are positive, so both NPVs can be the project can be invested, but NPV of this is higher than a project B, obviously. Also, one condition which you can check, since the next question asks you which project you will recommend, is the NPV of this is higher as possible. You can also do a quick goal seek to check that the IRR for which project is higher. I did, and I got an IRR of 13% for project A. So obviously project A has a better IRR than project B, and therefore it will follow project A. Now it is saying that suggests reasons for the finance director's decision that it might decides to implement the other project than project project A generates higher return, but then the initial cost of investments and risks is higher in that. And then project A has a cost saving through reduction in staff members. Okay, but then project B does not have reduction in staff members, and other project B involves IT setup, which will project B involves IT setup by its own company's employees, so that will save costs on outsourcing to a third party, and so on. So all these are dependent. All these are independent and will be more uh, profitable for the company in the long term rather than the short term. So yes, the finance director may decide to choose project B. So yes, this is the basic paper which had come for CM1 paper B. Overall, it was a good paper, but yes, question 2 was a bit lengthy. Depending on, we had to do all the 3 conditions, but yes, it had to be calculated once only, and then the other you need to had to just do goal seek and solve it. Thank you.